Hey guys, welcome back to the channel, and now in this video we will be understanding the Bohr's model of atom. And trust me guys, if you watch this video till the end, you will get to know everything regarding this Bohr's atomic model. So after Rutherford's atomic model was rejected, it was Niels Bohr who proposed the atomic model of an atom. What Niels Bohr did was that he simply modified the Rutherford's atomic model. So now let us understand what are those modifications made by Niels Bohr, or you can say what are the postulates of Bohr's atomic model. The first postulate is that electrons revolve around the nucleus in specific fixed orbits. Now you might be wondering that even Rutherford told us that electrons revolve around the nucleus in orbits. Yes, Rutherford did tell us, but it was Niels Bohr who said that electrons revolve in specific fixed orbits only. Rutherford did not specify in which orbits the electrons are going to revolve. So it was Niels Bohr who told us that electrons will revolve only in specific fixed orbits. And what Niels Bohr did was that he named those specific fixed orbits. How he named them? He named the first orbit as K, the second as L, the third as M, fourth as N, and so on. As you can see over here, that the first orbit is named as the K shell, the second as the L shell, the third as the M shell, and the fourth as the N shell. Now don't get confused between the shell. Shell and orbit is nothing but the same thing. Okay, so there is nothing to worry about it. Okay, moving ahead. But you might be wondering which are those fixed orbits, or what is the condition to identify those fixed orbits. Okay, so now let us understand the conditions to identify the fixed orbits in which the electrons are going to revolve. The first condition is that the angular momentum of the electron in the orbit must be L is equals to N into H upon 2 pi. Now I know that many of you might not understand this point, but trust me guys, keep patience for next 1 minute and I assure you, you will get to know everything about this. So he said that the angular momentum of electron which is revolving in any orbit is N into H upon 2 pi, where this H is nothing but Planck's constant, and the value of Planck's constant is 6.22 into 10 raised to minus 34 joule second, as we all know. And this N is nothing but the number of orbit in which the electron is revolving. Okay, so suppose your electron is revolving in the first orbit. So what you will do is that you will substitute the value of N as 1. So what will be now be the angular momentum of electron in the first orbit. So you get the angular momentum of electron in first orbit, which is equals to H upon 2 pi. Now similarly, if your electron is revolving in the second orbit, so if it is revolving in the second orbit, you have to substitute the value of N as 2 over here. So now you get the angular momentum of electron in second orbit as 2 into H upon 2 pi. So now I hope you all understood this point, that the angular momentum of the electron in the orbit can be found out using this formula, L is equals to N into H upon 2 pi, where your L is nothing but angular momentum, H Planck's constant, and N is nothing but number of orbits. So now if you have understood this point, so can I say that the condition for the first fixed orbit is that the electron in that orbit must have angular momentum H upon 2 pi. Am I right? What is the condition for fixed orbit? The condition for first fixed orbit is that the electron which is revolving in that orbit must have angular momentum H upon 2 pi. Similarly, what is the condition for second fixed orbit? The condition for second fixed orbit is that the electron which is revolving in the second fixed orbit must have angular momentum 2 into H upon 2 pi. Am I right? So now moving ahead. as we have seen that the angular momentum of electron in first orbit is nothing but 1 into h upon 2 pi. In the second orbit it is 2 into h upon 2 pi, and in the third orbit is nothing but 3 into h upon 2 pi. So what I have observed over here, and you should also observe, is that the angular momentum of electron in the fixed orbit is integral multiple of h upon 2 pi. Now what is the meaning of this integral multiple of h upon 2 pi? See, for finding the angular momentum of electron in any of the orbit, whether it be first, second, third, what you are doing, you are just changing this value of n, whereas this h upon 2 pi is remaining constant in all the three formulas. And what you are doing is that you are multiplying this h upon 2 pi by a integer 1, 2, 3. These are your integers. Can you see anywhere decimal numbers like 2.3, 3.4? No. You are multiplying h by 2 pi by a integer only. So this is what this statement said, that the angular momentum of electron in the fixed orbit is integral multiple of h upon 2 pi. Okay. So now if the electron follows this condition, then the electron will not lose energy. And if it is not lose energy, hence it will continue to revolve in the orbit for infinite duration of time. So this is what Niels Bohr proved us, that if the electron is following this condition, then it will not lose energy, and if it is not losing energy, it will continue to revolve around the nucleus in an orbit for infinite time. This was a major drawback of Rutherford, which was covered by Niels Bohr. Okay. Now if you want to know what is the model of Rutherford, you can find the link in the description box, or you can simply click on this I button over here. Okay. Now moving ahead, as we have seen now, that if you want to find out the angular momentum of electron revolving in any of the orbit, you have to use this formula, which is nh upon 2 pi. But in physics circular motion chapter, you will be studying that the formula for angular momentum is nothing but L is equals to mvr. So now if you observe here, the left hand sides are same, angular momentum, and as we all know that if the left hand sides of any equation are same, then the right hand sides will also be same. So can I say that mvr is nothing but equals to nh upon 2 pi. This is a very useful equation for solving numericals. Okay, where this m is nothing but mass of electron. Why we have taken mass of electron? Because it is the electron which is revolving in a circular orbit, whereas v is nothing but the velocity of electron, and r is nothing but radius of orbit. The radius of orbit in which the electron is revolving, we have to take that orbit radius. Okay. And as we have seen earlier, that n is nothing but the number of orbits, and h is nothing but Planck's constant. Okay. So now moving ahead, Bohr gave us another concept. What was that concept? He said that the energy of electron goes on increasing as the orbit is farther from nucleus. Now what he tried to tell us that, see, consider this electron is revolving in the first orbit, and this electron is revolving in the second orbit. So what he said is that the electrons which are in the outer orbit, for example the electron which is in the second orbit, will have more energy than the electron which is in the first orbit. Similarly, if you consider this electron is in the third orbit, and if you compare it with the electron in the first orbit, he said that the electron which is in the third orbit will have greater energy as compared to the electron which is in the first orbit. Now you might be wondering, why is it so? Okay, so now as we all know that the nucleus is positively charged, whereas your electrons are negatively charged. So since they are oppositely charged, therefore there is electrostatic force of attraction between the electrons and nucleus. So this nucleus will attract this electron greater as compared to this electron. Why? Because this third orbit electron is away from the nucleus. Therefore, electrostatic force of attraction due to nucleus reaching this electron is less. Therefore, since this first electron is close, it is attracted more, and as a result, it is not able to move freely. And if it is not able to move freely, therefore its energy will obviously be less. Now, can I say that, see, if I compare the electrons in the K shell, which is your K shell, the first orbit, or you can say the electrons in the K orbit with the electrons in the L orbit, can I say that the electrons in the L orbit, which is the second orbit, will have greater energy as compared to the electrons in the K orbit? So this is what I have written, that the electrons in the L orbit are having greater energy as compared to the electrons in the K orbit. Similarly, if you compare the L orbit and the M orbit, what you get to know is that the electrons in the M orbit will have greater energy as compared to the electrons in the L orbit. So guys, I hope this point is clear for you all. So now, on the basis of different energies, he said that if an electron wants to jump to the outer orbit, then it has to gain energy. Now what is this actually? As we have seen, this electron is revolving in the first orbit. Okay, and if it wants to go into the second orbit, but second orbit, for going to second orbit, it requires more energy. Why more energy? Because second orbit has greater energy as compared to the first orbit. So if it wants to go into the second orbit, it has to take some more energy. So how it will gain energy? You have to incident a light, a visible light or any other light. You have to incident a light on this electron. So after a light is incident on this electron, what happens is that, as we all know, that the light consists of photons, and photons are nothing but energy packets. So these photons will be absorbed by this electron. So this electron will absorb the photons in the light, and after absorbing a photon, it will gain energy. Now since it has gained energy, now it can move to the outer shell. So as you can see over here, this electron has moved to the outer shell. But since it is the state in which it has been supplied energy, am I right? It has gone to the outer state after gaining energy. So this state of an electron is known as the excited state, in which the electron has gained energy and gone to the outer shell. It is in the excited state now, okay, because it has gained energy. Now moving ahead, the reverse of it, that if the electron wants to jump in the lower orbit, then it has to lose energy. Now what does this mean? Suppose you have an electron which is in the second orbit and it wants to come into the first orbit. As we all know that the energy of electron in the second orbit is greater, and when it comes to first orbit, the energy will decrease. So it has to give away some energy in order to come to the first orbit, because the energy difference is there. So when it comes from second orbit to the first orbit, it will give away energy, and that energy will be given away in the form of a photon. And as we all know that photon travels in the form of a wave. So this is what you have seen in the previous slide, that if it goes from inner orbit to outer orbit, it has to gain energy in the form of photon, and when it comes from outer orbit to inner orbit, it will give away energy. So I hope this point is clear for you all. So now, but this Niels Bohr atomic model had certain drawbacks. Now what are those drawbacks? The first drawback is that Bohr's model fails to explain the atomic spectra for elements containing more than one electron. Now what is this atomic spectra? If you don't know what is atomic spectra, don't worry guys, I've already made a video on this. You can find the link in the description box, or you can simply click on this link above on the I button. Okay, so now he said he was able to prove the atomic spectra for one electron. Why he was able to prove the atomic spectra for one electron? Because Bohr's model was designed considering hydrogen atom. So with reference to hydrogen atom, Bohr's model was designed. And as we all know that hydrogen atom consists of one electron. But what happened is that as soon as the number of electrons increased, this Bohr model was not able to prove the atomic spectra. Or you can in other words say that when the element was changed from hydrogen to some other element, this Bohr's model failed to explain the atomic spectra. The second point is that the model fails to explain the splitting of atomic spectral lines in the presence of magnetic field. Now, the splitting of atomic spectral lines in the presence of magnetic field is known as Zeeman effect. So, the Bohr's model was not able to prove this Zeeman effect as well. You will get to know idea about the atomic spectral lines when you watch this video on atomic spectra. Okay. Similarly, it also failed to explain the splitting of spectral lines in the presence of electric field. This process is known as Stark effect, where the spectral lines are being splitted in the presence of electric field. Okay, so guys, this Bohr's model had certain drawbacks. So guys, although the Bohr's atomic model had certain drawbacks, but it was also useful for us in the further discovery of structure of atom. So now let us understand the important features of Bohr's atomic model. In this video, we are going to now understand the two important features. Okay, so let's start with the first feature. That is, we can find the radius of Bohr's orbit. Okay, so Bohr orbit is nothing but the orbit in which the electron is revolving around the nucleus. But how can we find out the radius of Bohr's orbit? Let's understand how. See, there is a Coulombic force of attraction between nucleus and electron. As mentioned earlier, that this nucleus is positively charged and this electron is negatively charged. Now, since they are oppositely charged, therefore there will be force of attraction between the electron and nucleus. This force of attraction is known as Coulombic force of attraction between nucleus and electron. And the formula for this Coulombic force of attraction is nothing but Z square upon R square, where this Fc is nothing but the representation of Coulombic force. This Z is nothing but the atomic number. Now, what is the meaning of this? Suppose you are considering a hydrogen atom, then you have to substitute the value of Z as 1 because the atomic number of hydrogen is 1. Suppose you are taking carbon atom, so you have to substitute the value of Z as 6 over here. Why? Because the atomic number of carbon is 6. And this E is nothing but charge of electron. And as we all know that the charge of an electron is nothing but 1.6 into 10 raised to minus 13 coulombs. And this R is nothing but the radius of orbit. Now, what is the meaning of this? See, suppose you want to find out the Coulombic force for an electron which is in the second orbit. Suppose you want to find out the Coulombic force between this electron and this nucleus. So what you have to do, since this electron is in the second orbit, therefore you have to substitute the radius of second orbit from the nucleus. And how you calculate radius? Radius is nothing but the distance from nucleus till the second orbit. Why? Because you are considering the electron which is revolving in the second orbit. Similarly, suppose you want to find out this Coulombic force for an electron which is revolving in the first orbit. So obviously you will take the radius of the first orbit. That is nothing but the distance from nucleus till the first orbit. Now I hope this formula of Coulombic force is clear for you all. Moving ahead, there is a concept to be understood now. See, for any body to revolve in a circular path, it must have centrifugal force, which means that any body which is revolving in a circular manner must experience a centrifugal force. And if it does not experience a centrifugal force, then it won't be able to move in a circular orbit. Now let's understand what is this centrifugal force. This centrifugal force is nothing but a force experienced by a body moving in a circular path. And this force is experienced away from the center. which helps the body to keep revolving in circular path. Now, what is the meaning of this? The body which is moving in a circular path experiences a force away from the center, and as it is experiencing force away from the center, therefore this body continues to move in the circular path and does not come closer to the center. Okay, and what is the formula for this centrifugal force? Centrifugal force nothing but equals to mv square upon r. So I hope you have understood the use of centrifugal force. The centrifugal force keeps the body revolving in a circular manner. It is not the case only for electron. For any body which is moving in a circle, it needs centrifugal force to move in a circular path. Regarding this centrifugal force, you will be learning in depth in the chapter circular motion. Okay, so now for now we have to just remember the formula of centrifugal force is nothing but equals to mv square upon r, where this m is nothing but mass of electron and this v is nothing but velocity of electron. Now why are we considering the mass and velocity of electron? Because in an atom it is the electron which is moving in a circular path. Therefore, for our reference, we are considering the mass of electron and the velocity of electron in this case. Now, as we all know that any body which is moving in a circular motion requires a centrifugal force. So it is obvious that this electron is moving in a circular path, therefore it will also require a centrifugal force. So now who is going to provide a centrifugal force to the electron? As we have seen earlier that there is already a Coulombic force present between the electron and the nucleus. Just now we saw, am I right? So this Coulombic force will be used as centrifugal force by the electron and it will keep rotating in a circular path. Okay. So centrifugal force is obtained with the help of a Coulombic force. So centrifugal force is nothing but equals to Coulombic force over here. And what is the formula for the centrifugal force? Centrifugal force is nothing but mv square upon r, which I have seen just now. And the formula for Coulombic force is nothing but z e square upon r square. Now just rearranging those terms, after rearranging we get the value of r as z e square upon mv square. So here guys, we have find the formula for radius, and this is the first feature of Bohr's atomic model. That is, it gives us a formula to find the radius of orbit which we want. Okay, now moving ahead, we will just simplify this formula of radius. Okay, now earlier in this video we have seen that the angular momentum mvr is nothing but equals to nh upon 2 pi. From here we get the value of v as nh upon 2 pi mr. We are just moving this m and r on the right hand side, therefore when they go on the right hand side they will come in the denominator. So from after rearranging the terms, we are getting the value of v as equals to nh upon 2 pi mr. Now what I am going to do is that I am going to substitute the value of v in the first equation. And what is the first equation? R is equals to z e square upon mv square. We have seen it just now that the radius formula for radius is nothing but z e square upon mv square. So now here we are going to substitute the value of v from this equation. So this v will be replaced by this formula, that is nh upon 2 pi mr. So after substituting the value of v, what we get is that r is equals to n square h square upon 4m pi square z square. And I hope you know what is the meaning of these terms. This is but the number of orbit in which the electron is revolving, and this h is nothing but the Planck's constant, and this m is nothing but the mass of an electron, this z is nothing but the atomic number, and this E is nothing but the charge of an electron. Now guys, suppose you substitute the value of 1 over here, n as 1. So suppose you substitute n is equals to 1. So you will get the radius of first orbit. Suppose you substitute the n as 2 over here. Now you will get the radius of the second orbit. And how is radius calculated? Radius is nothing but the distance from nucleus till the orbit. So I hope this formula for radius is pretty much clear for you. Moving ahead with the second important feature of the Bohr's atomic model. That is, it gives us the energy of electron which is revolving in an orbit. So the formula for energy is nothing but minus Ze square upon 2r. Now what I am going to do is that I am going to substitute the formula of r in this equation. And what is the formula for r? We have seen it just now. That is n square h square upon 4m pi square z square. So we substitute the value of r over here. What we get is that energy is equals to minus 2 pi square mz square e raised to 4 upon n square h square. So similarly, like the previous one, like the radius, suppose you substitute the value of n as 1 over here. So you will get the energy of electron which is revolving in a first orbit. Suppose you substitute the value of n as 2 over here. So you will get the energy of electron revolving in a second orbit. So guys, this was all about your Bohr's atomic model and its important features. So guys, do check out my channel where I uploaded physics and chemistry videos. They might be helpful for you all. And guys, please don't forget to subscribe to the channel so that whenever I upload a video, you will get a notification about it. Guys, thanks for watching this video.